In this video, I'm going to solve these 8 questions from the chapter integrals. As you can see, I've taken questions both from definite and indefinite integrals. There are questions involving direct application of properties. We have some questions based on substitutions and also questions involving properties. This one will be solved by using direct application of the formula. So let's begin with the first one, including this eyelet, that is integration by parts. So let's begin with the first one. Now, in this question from the chapter integration, in fact, definite integration is what this question is, and this is what the function. So what we are going to do in the first go is to split them. So I'm going to write this as limit minus 2 to 2. This is x cos x dx plus integration minus 2 to 2. This is sin x dx and plus integration 1 dx or simply dx minus 2 to 2. Now next what we are going to do is to apply the product rule. And if I write I late, then algebra will come first. So clearly this being our first and this being the second function. So this way if I integrate, this is going to be I as it is integration. Well, integration of applying eyelet, right? So first term is as it is, integration of cos x is positive sin x, and let's place the limit over here. This is minus 2 to 2 minus whole integration d by dx of x, which is 1, which is going to be 1, and integration of cos x is positive sin x dx. And copying the rest part, this is integration minus 2 to 2. This is sin x. In fact, we over here, we can see that this is 1 dx whose integration is what? X, and the limit is minus 2 to 2. Now you can see that this and this get cancelled. So we are left with, let me write down what we are left with. We are left with I is equal to integration. We have to place the limit. Integration is done, right? So if I place the limit over here, this is going to be what? 2 sine 2x and minus 2 sine, not 2x, 2 sine 2 and minus 2 sine 2. And over here, if I place the limit, this is positive 2. 2 minus, and since we have a minus, so minus of minus 2 will give you plus 2. So this get cancelled. This is 0 plus 4. So 4 is the answer after evaluating. Now in the next question, we have to integrate this function, that is sine 2x over sine square x plus 2 cos square x. Now what we are going to do is to replace this sine square x with 1 minus cos square x. This way we will have the whole denominator in terms of cos. So keeping the numerator sine 2x as it is and dividing it by, the only thing I'm going to change here is replacing sine square x as 1 minus cos square x, keeping this plus 2 cos square x as it is dx. Now simplifying the denominator part. So what I can write the denominator as 1 minus, sorry, it's going to be 1 plus cos square x. Right, this is minus cos square x and plus 2 cos square x should result to give you what? Cos square x, positive. Now, next I'm going to do substitution. In the substitution, I'll take 1 plus cos square x as, say, t. So it's going to be minus 2 sine, minus 2 cos x dot sine x dx is equal to dt, right? So this is dx, right? What I wrote over here. This is dx is equal to dt. So what I did is simply differentiation of 1 is what? 0, and applying the chain rule, we got this. So this can be written as what? As you know that 2 cos x sine x is 2 cos x sine x is sine 2x. So I can write this as minus sine 2x dx. is equal to dt. So I can place one minus over here. This is minus over here and minus over here. So this is going to be minus and 1 over t dt, right? So in the final step, we are going to write this as minus log t plus c. And finally, to replace t with what I assumed as t as this. So it's going to be log 1 plus cos square x plus c. So this should be our answer. Now this question from definite integrals, which is based on this property, that is fx from limit a to 0 to a, can be written as integration a to 0 fa minus x. So let's say if I apply this property in sin x, cos x, and below also, what we are going to get. So we can see that this is what I write as equation 1, the question itself. This can be applying the property is going to be 0 to pi by 2. This is going to be sine a minus x, that means pi by 2 minus x, minus cos a minus x, that is pi by 2 minus x. Same we are going to do below, that's 1 plus sine pi by 2 minus x multiplied by cos, this is pi by 2 minus x dx. So what we know that sine 90 minus theta is cos theta, right? So this is what we are going to do, and cos 90 minus theta is sine theta. So this will give you cos x minus sine x, and below this is 1 plus, this will become sine, will become cos x into sine x. Now we are going to mark this as equation 2. Now check here, if I add this equation 1 and 2, as you can observe, on the left hand side I plus I will become 2 times I, and on the right hand side you can see that we have the same denominator, this and this having the same denominator. So we can write this as 1 plus sin x dot cos x, and then we are supposed to add the numerator, and the numerator is what, sin x plus cos x, and here is cos x minus sin x. On adding this, what we are getting? We are getting 0, right? So therefore we can say that 2i is equal to 0 implies I is equal to 0. So the correct answer here is I is equal to 0. The next question is to write the value of this. We have e raised to the power x over 1 plus e raised to the power 2x dx, and the limit is 0 to 1. So what I'm going to do, let's say if I write I is equal to 0 to 1, we'll be doing substitution. This is e raised to the power x plus 1. Can I write e raised to the power? Can I write e raised to the power 2x as e raised to the power x whole square? We can do, right? Now we are going to apply substitution. Here I'm going to put e raised to the power x as t. That implies it's differentiating both sides with respect to x. E raised to the power x dx is equal to dt. Well, we have to change the limit as well. So when x is equal to 0, placing x as 0, what we are getting? T as e raised to the power 0. Any number raised to the power 0 is 1, right? So t is equal to 1. And in the next go, when I place x is equal to upper limit, which is 1. So placing 1 over here, we are getting t as what? E raised to the power 1, which is e only. Now with the new limit is going to be 0 to 1. It was 0 to 1. Now it is 1 to e. Replacing this with dt. So this is 1 over 1 plus, replacing this with t, is going to be t square dt. Now, what is this? This is tan inverse t. So this is tan inverse t, and the limit is 1 to e. So now we are going to place the limit, that is tan inverse, placing the upper limit as e minus tan inverse 1. Right, is it done? Now we can still apply the property of tan inverse A minus tan inverse B, that is tan inverse A minus B over 1 plus AB, right? Don't write plus C because this is a definite integration. So I'll say that this is the final answer in this case. Now the next question is to evaluate this. We are not going to apply properties over here. It cannot be solved by properties. Instead, we'll be applying integration by parts. And applying ilet, I can see this is going to be the first and this would be the second function. So proceeding with this only, that is first is x square as it is, first function as it is, and integration of the second function sin x, right? Integration of sin x is minus cos x. So minus over here and cos x minus whole integration and dy dx of x square is what? 2x. So I'll write 2 over here and 2x. And then once again, integration of sin x. Sin x integration is what? Positive, negative cos x. So I should make this negative as positive and cos x dx. This is cos x dx. Now check over here. We can apply ilet once again. Not up. We have to apply this. Now check here. This is minus x square cos x plus 2. So first function has to be this only, and this is going to be our second function. So first function as it is, and integration of cos x is positive sin x minus whole integration d by dx of x, which is 1. You may not write 1. 1 is a multiplicative identity, and cos x integration is what? Positive sin x dx. So let me tell you this part again. We are applied ilet over here. So x as it is, integration of cos x is positive sin x minus whole integration d by dx of cos x, which is 1, and then integration of cos x, which is positive sin x. We have one more step for the final integration, and I should write down the limit. This is 0 to pi by 2. So this is I is equal to minus x square cos x plus, this time I'm opening this bracket, to 2x sin x, 2 over here, right? This 2 minus 2, and then integration of sin x is what? Negative cos x, so it's minus cos x. And the limit over here is what? 0 to pi by 2. Next is, so now I'm going to place the limit over here, placing the upper limit, which is pi by 2. So it's going to be placing the upper limit over here, that's pi square by 4 cos pi by 2 plus 2 times pi by 2 sine x will be replaced by pi by 2, and this is 2 times cos pi by 2. That's the upper limit, right? And minus the lower limit. So placing x as 0, this will become 0. Placing x as 0 here, this 2 will become 0. And placing x over here, this is cos 0 is what? 1. So that is 2 into 1 is 2. I can use this space over here. So this is minus pi. And what is this? Cos 90, right? This is cos 90 is what? Cos 90 is 0, right? So this will become 0. So this is 0 over here, right? Plus this is sine 90 is 1, and this get cancelled. So it's pi into 1 is pi, right? And this is again cos 90, which is cos 90 is 0. So this whole thing will become 0. That's the upper limit, and minus 2 is the lower limit. So actually it is pi minus 2. Yeah, that should be the answer. Pi minus 2 will be the final answer. Now check on this question. We have to integrate this, and the limit is minus pi by 2 to pi by 2. Now, in such a case, we need to check whether the function is odd or even. So we have fx. Let's say if I take fx as what? Sine raised to the power 9x. So what is f? What we used to do? If we know fx, then we used to find f minus x. So this is sine raised to the power 9 minus x. With an odd power, you know that it's going to be, the power is odd over here. So it's going to be sine raised to the power 9x. This is f minus x only. So we get f minus x as, I can replace this with fx, so it will result to give you minus fx. So what we know that if f minus x is equal to minus of fx, then we say it's an odd function. Fx is an odd function. So if this is an odd function, it implies that its integration is going to be 0. That's what we will do. The next question is to integrate this, that is x square into x e raised to the power x cube. We'll be applying substitution for this. So what I'm going to do is to take x cube as t, that means 3x square dx is equal to dt. So by substitution, what we can see that we need a 3. So I'll write it this as 3 and 1 by 3, right? This is x square into e raised to the power x cube, right? So what you can see that this x cube is going to be replaced with t, and this is going to be dt, right? This is going to be dt. So now this becomes what? I is equal to 1 over 3 integration e raised to the power t dt, right? There is a nothing, right? We just need to integrate this. E raised to the power t integration is e raised to the power t plus c. And in the final step, we are going to replace t with x raised to the power 3 plus c. Yeah, that should be the answer in this case. The next question is to evaluate this. Now, for solving this indefinite integration, what we are going to do in the first step is to split this. And for splitting, what we are going to do is to write minus 7 say outside, and this is x over 16. That's under root. This is under root 16 x square minus 9 and plus 2. This is dx. Well, dx should be here also. That divided by under root 16 minus x square minus 9. So this is I1 and I2. So what I'm going to do is to solve the I1 first. Now from here you can figure out that the differentiation of this is what? If I take this as t, let's say if I place 16x square minus 9 as t, is going to give you what? 32x dx is equal to dt. So we need a 32 over here, and that's why I divided by 32. So that results to give you what? In the first part, this is I is equal to, say I'm talking about the I1 over here. This is minus 7 over 32 integration 1 over t raised to the power half, right? Under root t is t raised to the power half dt. Now, let's continue solving I1 only first. This is I is equal to minus 7 over 32. This is t raised to the power minus half, I can say, right? This is integration t raised to the power minus half, right? That's what I mean to say. So its integration is what? T raised to the power minus half plus 1. So this is going to be t raised to the power minus half plus 1, and that divided by this, which is what? Half only. So now we can say that I is equal to minus 7 over, I will divide it. This is 2 over 1, right? Dividing by half is same as multiplying with the reciprocal. And this is going to be t raised to the power positive half. That is t raised to the power positive half, right? So t raised to the power positive half is what? Under root t, and under root t, and I'm replacing t over here, trying to simplify within a single screen. Yeah, this is what we can get from I1. Now for solving I2, we are going to apply this formula. That is this one, right? So this is plus 2. And first I'm writing this question in the form of the formula. Can I write this as 4x square minus 3 square? Well, I'm going to consider 4x as x only. This is 2. Applying this formula, integration is what? This is, its integration is log mod x. Well, x is 4x, right? For us, x is 4x plus integration, the question x square minus this I as is nothing but the question only. So this is how much? 16x square minus 9. But you have to remember that I have considered this to be x, which is not an x over here. So I'll have to divide by its differentiation. So 4x differentiation is what? Dividing by 4. So dividing by 4, that results to give you half. So if I continue writing, this is log, half log mod 4x plus under root 16x square minus 9 plus c has to be there. Right, so this will be our answer. This should be the answer for this question.